Hi everyone, just doing this video after a quick comment from Ash here, who's asked, can I do this question in binary, number part I? I said I could do it in the video like this. Looked at the video, thought, can I do that in binary? I've decided, yes, I can do it in binary. So let's have a quick look. It is lovely in binary as well, actually. I forgot how nice this one was. Now, yeah, we're told here f of 1 is 1, f of 2 is 2, f of 3 is minus 1. You know, what are they playing at? And then we've got these obscure kind of like inductive kind of, you know, it feels very inductive to me anyway, way of building up what all of the values for f are from 1 to 100, because we're told if you double f of k, then it's, you know, sorry, if you double k, then that will take the same value, yeah, when you apply f to it. And if you do 2 times k plus 1, it will take the same value as when you apply f to it, yeah, and this allows you to build up the whole sequence. Now, you know, initial thoughts when you get this question are like, blimey, this is going to be a really kind of like this. We're basically building up all the values from f of 1 up to f of 100, and they're obviously all taking the values of 1, 1, or minus 1. Clearly, minus 1 is the awkward one, yeah, and clearly that starts at 3. Now, let's talk binary. Now, okay, hopefully everybody's aware of how binary works. Let's say I'm doing the number 15, just to quickly check that you're aware of how binary works. Basically, binary is a series of 1s and 0s, but the 1s and 0s represent multiplying by powers of 2. So if I want to write binary down, and skip this part of the video if you're already aware of this, then I need, essentially, a 2 to the power of 0, so I'm going to times that by 1. I need a 2 to the power of 1, so I'm going to times that by 1. Yeah, and you might think, how do I know what I need? You can build this basically. You want to start at 8 really. You think, you know, because that's a power of 2. 8 plus 4 plus 2 plus 1 is 15. I think that's right. 8 plus 4 plus 2 plus 1, that's 15. And so I need 1 times 2 to the 0 plus 1 times 2 to the 1 plus 1 times 2 squared plus 1 times 2 cubed. Yeah, and that is there, and therefore 15 in binary is 1, 1, 1, 1. Yeah, and 16, by the way, would be 1, 0, 0, 0, 0, because all you need for that is a 1 times 2 to the power 4, plus 0 times 2 to the power 3, plus 0 times 2 squared, plus 0 times 2 to the power 1, plus 0 times 2 to the power 0. So that's 16 is that in binary. So that's how binary works. Look into it. It's well worth doing. Look into how to add and multiply in binary. Yeah, I should know off the top of my head, but it's been a while since I've used binary, so maybe I'll do a video on it if I get a time. Anyway, I wanted to do this quickly because I'm going out in a second, but okay, so what are our problems here? Well, clearly, like when we're going up from 1 to 100, I'm basically interested in 3 and what happens to 3 after we double it. We get 6 after we double, you know, and that's going to be also a minus 1. What about like when we double, because I know f of 6 is minus 1, then I know f of 12 is going to be minus 1, then I know f of 24 is going to be minus 1, and so on and so forth. But it's not just 3, 6, 12, 24, 48, etc. You've also got the, you know, and you could also combine it with this one as well, yeah? So this one's telling us whatever f of k is, you know, f of 2k plus 1 is also the same. So for example, f of 7 equals f of 3, yeah? But remember, because of this one, f of 14 equals f of 3. So, you know, or you could do f of 22 equals f of 3 because f of 7 equals f of 3. So there's all sorts of awkwardness going on in this question until you work with binary. Now, what is 3 in binary? 3 in binary is going to be a 1 and a 1, and that's because you need 1 times 2 to the 0 plus 1 times 2 to the power of 1 to make 3, yeah? Now think about what happens, because this is basically saying double it, and this is saying double it and add 1, yeah? How do we double in binary? Well, when you double in binary, you times everything by 2, yeah? And if I was to times something like this by 2, then I increase the power on that one, you know, so that's going to become like a 1 times 2 squared. I increase the power on this one, so that's going to become 1 times 2 to the power of 1, yeah? And if you like, there's an invisible 0 times 2 to the power of 0 at the end. In other words, when you times 3 by 2, you get 6, and 6 in binary is 1, 1, 0, yeah? Now you'll find, after just a quick bit of thinking, that doubling in binary means appending 0. Yeah, and I mean append, not prepend, but append 0. You stick a 0 on the end when you double a number in binary, yeah? And guess what? If you're doubling and adding 1 in binary, double then add 1, well, that is append 1, yeah? For example, Double 3, add 1, you get 7. What is 7 in binary? It's a 1 and a 1 and a 1. See? So if you start with 3, which is 1 and 1, yeah, doubling it means put a 0 on. Doubling and adding 1 means putting a 1 on, yeah? Now this gives us a lovely way of doing this, because we're worried about basically what can happen to 3. Well, 3 is 1 and 1, yeah? I now know, and I'm trying to count, going up to 100, all of the values. I'm trying to consider all of the values, sorry, which are, you know, minus 1, because all the rest are going to take a value of 1, yeah? So I'm trying to think of all the minus ones, because I know that all the other ones are just going to be 1 plus 1 plus 1, yeah? So what are those? Okay, well, let's have a look. So we've got, okay, we'll start with 1 and 1, which is 3, yeah? I'm working in binary. Now, I know that if I stick a 0 on the end, yeah, or if I stick a 1 on the end, I'm going to also have these problem ones. These are all the minus 1s which are going to be involved. All the rest will be 1s, yeah? Now, before I keep doing this, and I kind of, sorry if I break my train of thought frequently in an explanation, I really am terrible with that. But I'm in a rush as well this evening, so I'm heading off out. But yeah, if I consider how far I need to go with this tree, that'd be really useful. So let's quickly write down 100 in binary. Now, if I want to write down 100 in binary, that's 100. I should write in the words really, because otherwise it looks like binary. But yeah, it looks like the number 4. But never mind about that. This is 100. This is a normal 100. Yeah. What is it in binary? Well, in binary, you'd need a 2 to the power of 6 for the 64. You'd need a 2 to the power of 5 for the 32. We're already at 96, yeah? Okay, so we don't need any 2 to the power of 4s. We don't need any 2 to the power of 3s. We just need another 4, which is a 1 times 2 squared. And then we need 0 times 2 to the 1 plus 0 times 2 to the 0, yeah? Cool. So in other words, in binary, this is 1, 1, 0, 0, 1, 0, 0, yeah? Brilliant. I know I've got to go that far. Now I can super fast actually add up all the possible minus 1s there are out there, yeah? So what are all the possible minus 1s? Well, they are, start with 3, we've got 1 and 1, but then we know we've got a really quick way of counting these now. You can stick a 0 on the end or a 1 on the end. That represents doubling and adding 1. And then with these, you could stick a 0 on the end, or you could stick a 1 on the end, and same here, you could stick a 0 on the end, and you can stick a 1 on the end, yeah? Now, I'm not going to continue this tree, because I can immediately see the pattern. I need to go, you know, I'm going to have 1, 2, 4. I need to go to the 5th bits, yeah? Yeah, I think they're called bits. I'm not great with computing. Well, there's going to be 8 possibilities with 5 digits, yeah, in binary. And this has got 7 digits, have you noticed that? So we're going to need another 16 for the ones off of there, yeah, because there's going to be 16 of those, you know, etc, etc, etc. These represents, yeah, these are 4 digits. These are 5 digits. These are 6 digits, yeah. And then we just need to consider the extra few for the 7th digit. Now, remember, we're only going up to this far, so we know it's going to start 1100, yeah, because that's at 96. And we just need to consider basically at 110, and we're just looking at the ones with 7 digits because I've counted all the 6-digit ones now. So for 7 digits, what are we going to have? Well, we're going to have like, it must start with a 1 and a 1 because that means it stems from the 3, yeah. So you could have 1100, 000, yeah. You could have 1100, 001. You could have 1100, 010, 1100, 011, yeah, okay, right. And then we're going to get to this one, 1100, 100. Okay, I think that is all the ones I need to consider. I think there's 5 there, yeah. Okay, I've got to 100 now, yeah. Any further and I'll be a number bigger than 100 because I'll be affecting the most significant bits, as they're called in computing, rather than the least significant bits. Okay, add them up. We get 1 plus 2 plus 4 plus 8 plus 16. What is that? 31? I think it is. It should be because it's 2 to the n minus 1. 24, 28, 30, 31 plus 5 is 36, yeah. So we've got 36 minus 1s. All the rest, F1 to F100, will be 64 positive ones, yeah. And what happens if you've got 64 times 1 minus 36 times by, I'm writing down the answer too quickly, minus, you know, or plus 36 times by minus 1, what does that come to? 30, 64, 54, 44, 34, take off 6, it comes to 28, which I hope is the answer I got doing it whatever other crazy way I did it. That is what I mean, Ash. I hope that makes sense. It's nifty little method. Binary on lots of maths questions, it really does help. Don't go in there not knowing binary, that's all I'd say. It might not come in handy at all, but it doesn't take a second to learn a little bit of binary, and actually in that particular case I think it makes that question super quick, because you don't even have to go right the way through to the end. You start getting a feeling for a while. It's not that, you know, it's not that, it's not that, it must be this, it can't be that, there's not more negatives than positives. You know, once you get as far as a 16, you're like, I think I pretty much know what the answer is going to be. Okay, hope the video is useful. Best of luck in MAT or STEP or whatever it is you're taking, A-level maths, whatever. Good luck. Bye bye.